Okay, so adding and subtracting rationals. This is section 8.4 in your book. We're going to do just like we did in our bell work. We're going to get a common denominator. Then we're going to add or subtract the numerators and keep that common denominator, and then simplify what's left. The big thing is, if there's something to factor in a denominator, factor it. So, I'm going to write a step 0. Step 0. You know, sometimes Gina and I have different ideas about what should be done first. And so, I feel we should factor first. All right, here we go. Here are the simple ones. They already have the same denominator. Now, she wrote like base, but that's the denominator. Okay? So, looking at this one, the denominator is already the same. So, we do our steps. We add the numerators. 13a plus 5a is 18a. And we divide that by 4a squared. Oh, look. You're going to get more practice on the stuff you did yesterday. Woo! So, we reduce 18 over 4. What's that going to give us? 9 over 2. They're both divisible by 2. And then we reduce a over a squared, which will be a on top or bottom? Bottom. Remember, there's an understood 1 here, so when you subtract them, you get -1. That tells us it's going to go on the denominator. Now, adding and subtracting, I don't expect you to do restrictions. Okay? Technically, they still apply, but on your test, you are just going to assume that everything will work out for the adding and subtracting. Okay? All right, so number 2, we just have to be careful because you have this minus. That means we're going to treat this like a -7 and a -2. Remember when you first learned negatives in middle school, you would change it to a plus sign, and then those negatives change it to adding a negative? Maybe. All right, so we have 9 and -7 gives us 2x. 12 and -2 gives us 10. Keep the denominator. And this is a tricky form of reducing. 2 ways you could do this. You could just say, okay, 2, 10, and 16 can all be divided by 2. Or you could factor out the GCF of 2. When we get an answer, we simplify. So I'll factor out a GCF of 2. And then I can reduce the 2 over 16 to 1 over 8. Isn't that the same thing you would get if you divided each of these by 2? Yes. I don't care which way you do it. I did it this way so that you could see the rules that we learned yesterday still apply. Anna. So, 3. We have a common denominator. I'm actually not going to factor this yet because the denominator is already the same. But I am going to add. So, y squared, there's not another y squared. 8y plus 2y is 10y. And then you have your 21. Keep the common denominator. Now, it'd be great if this is all we had to do. And we could say, ha, I did it. Yay, I'm so smart. I added rational expressions. But that's not what happens. We're going to have to factor now and simplify. So when I factor this numerator, they're both quadratic. So I'm going to get 2 binomial terms there for each one. When I factor the numerator, I can use the shortcut because there's nothing in front of this y squared. So y and y. 21 is going to be 3 and 7. Those are the factors of 21 that add to 10. You want them to add to 10. What do we have in the denominator? We have a difference of squares. I want y'all to know that name. We have a difference of squares, And we take the square root of each. So y and 3, put a plus minus. We're almost there. Last step, cancel out the y plus 3's. So you have y plus 7 over y minus 3. What questions do you have?